Hello and welcome to the WSMX programming training. In this lab recording, we're talking about lab number 5, dynamic specification variable modification. Or in other words, we are talking about how to dynamically modify specification variables. So by that means in the execution part of a test flow, we want to pass on a new value for a specification variable, which then is used for the execution of the test suite. So that is not that, let's say, easy, because we gonna do this by using the device setup API. And as you know, the device setup API is used in the setup method of a test method to create specification files and specification variables. And the setup method is only executed once when we first run the test program. But later, if we have multiple executions of the test program, only the execution part is executed. So the setup part of the test method is not. So that means we already have to take into account the possibility that later in the execution part of a test flow, we want to change a specification variable of a test suite. Um, there are many different use cases where this is helpful or recommended. Probably the easiest one is that, for example, you have some results from some previous test suites, from some other test flows maybe, and you have them uh, saved in a global variable, and then later at a certain point in the test program execution, that has an impact that you want to change a specification variable of a test suite, and then we can pass on this global value and dynamically change a specification variable. Okay, lots of words. Long story short, it might be very useful. Maybe we talk about it a little bit later in another lab recording. So with that, let's jump into the lab manual. Um, as usual, we will continue with the WSMX_lab program. It's the one which we used in the previous labs. If you're running your labs in an offline session, please keep in mind that you have to follow the suggested file names and the capitalization to get the correct offline result emulation. Otherwise, it will not work. And in this lab recording, I will key in some test method code during this recording. So I will use the content assist, which is control space. There are a lot of other very useful shortcuts. And for that, I would recommend you that you also check out the reference card section at the end of this manual. And yeah, with that, let's go to the task 5.1. And for that, I would say that we directly jump into the smart test session, and the lab manual here goes into the other screen. And now we're gonna just step by step follow all the bullet points under task 5.1. And first one is that we take the test method here, uh, distortion AC underscore device setup API, and we copy it. And then we also paste it here in the distortion AC package. We just paste it here, and then we have, of course, to change the name. And here we're gonna use distortion AC underscore DS API, and then I want here also an underscore mod variable. Please keep in mind that you have to use this exact name if you're using an offline session. Let's click OK. And then please don't forget to really click into the newly created test method. Always check here that one, because in this editor window here, it does not automatically jump into the new test method file. Okay. Um, then first thing we have to change the type of the measurement from eye measurement to eye local measurement. Uh, let's save this here. Yes, now the arrow highlighting is gone. And here I would take the time to shortly discuss why we are using an iLocal measurement type. So for that, I would also recommend you to check out the TDC and just type in iLocal measurement. You will end up here. And here it says that when using an iLocal measurement, local copies of the specifications and operating sequences are created during the bind time. And this makes changing measurement properties or specification variables faster compared to changing properties of an iMeasurement measurement object where specifications and operating sequences are copied on write. So in short, if we use the iLocal measurement in this particular use case of dynamically changing a specification variable, we have a performance benefit. Okay, so we changed that one. Then also the lab manual asks us to instantiate a new string variable with a variable name, and that goes to SRC amplitude, and then we also have a capital V at the end here. Very good. Then we should go and scroll down to the setup part of the test method. And here first, before the AWG setup, we actually add a new variable to the specification or to the device setup API. For this we type ds add variable, and here we have it. And we take the one with the double variable here, and then I think for the setup variable type we use setup variable type, and then we take a voltage. Here we go. This is all using the device setup API. Here it already gave us some suggestion, but that is wrong. Here we want to have the variable name, which we instantiated just before. And here we go and use the SRC amplitude, that one here. Okay, so now we added a new variable to the device setup API. Then next step is that we actually comment that one out here, and we have here set amplitude, but now we are using the variable name. Okay, and then under bullet point number 6, oh, we don't need a semicolon here. Very good. And then we scroll down, and under bullet point number 6, we supposed to actually add here a new statement that for the measurement object, for the associated specification, we set a variable, and here we have the variable name exactly, and here we also go for SRC amplitude. Here we go. Okay, no arrow highlighting here. We save the test method code, and let's shortly jump into the lab manual. That was bullet point number 6, and I think with that we are done with task 5.1. And we will continue with the task 5.2 in the next video. Okay, so hear you later. Thanks and bye bye.